When we think about life on other planets, little green men and UFOs come to mind. But extraterrestrial life could be a little simpler than that. One of the moons of Jupiter, Europa, is suspected to have a water ocean beneath its ice crust surface, which theoretically could hold ocean life forms. In 2024, NASA plans to launch an interplanetary mission to study the moon and analyse the subsurface ocean there. Meet the Europa Clipper, the spacecraft that may lead to humanity's first discovery of life on another planet. Europa was first discovered by Galileo Galilei on the 8th of January 1610, along with Jupiter's other moons, Io, Ganymede and Callisto. Exploration of Europa, however, didn't begin for almost 400 years in 1973, when Jupiter flybys of Pioneer 10, and 1 year later Pioneer 11. They took close-up photos of the moon. These photos were low resolution, but in 1979 Voyager 1 and 2 took much more detailed images of Europa's icy surface, which led scientists to speculate about the possibility of a liquid ocean underneath Europa's icy surface. These images showed long linear features that hint at a layer of liquid between the crust and the deep interior of the moon. The ice crust is thought to be about 10 to 15 miles thick, with the ocean beneath between 40 to 100 miles deep. While Europa is only 1/4 of the size of Earth, this would still mean its oceans could contain twice as much water than all of the Earth's oceans combined. The Galileo probe, which studied Jupiter and its moons from 1995 through to 2003, provided a much greater examination of Europa. Jupiter's other moons also have an icy surface. However, Galileo noted that Jupiter's magnetic field was disrupted in the space surrounding Europa. This unique magnetic signature has led many leading scientists to think it was created by a global ocean of salty water. As Europa is very far from the Sun, we would not generally suspect the water to be liquid. However, its orbit of Jupiter creates a tidal tug and pull, which causes Europa to flex up and down. The theory is that the tidal energy turns to mechanical energy, and all that friction and heat could maintain a liquid water ocean beneath Europa's icy crust. There's also evidence of large water plumes shooting up from the surface and launching water vapour into space. Using data and images collected from the Galileo spacecraft, a model has been suggested for how a combination of freezing and pressurization may lead to cryovolcanic eruptions. The radiation that Europa is blasted by is also theorized to be able to help life forms survive. Unlike photosynthesis that all life on our planet uses, perhaps the radiation creates fuel for life in the oceans below the icy surfaces. These life forms are not likely to be the aliens we are used to seeing in our science fiction films, but could be simple organisms like bacteria. The Europa Clipper is planned to prove these hypotheses. Planned to launch on the 10th of October 2024, the Europa Clipper will take a 6-year journey to the Moon, using gravity assist manoeuvres involving both Mars and Earth to help it in its travels. The spacecraft has solar arrays stretching 72 feet, which will provide power on its long mission and will provide 150 watts continuously when pointed towards the Sun. Obviously, whilst in orbit, that won't always be an option, so the Europa Clipper also has batteries to enable continued work even while in Europa's shadow. Europa is bathed in radiation from Jupiter's magnetic field. This would play havoc with the instruments on Europa Clipper, so they have all had to be enclosed in a thick vault made of titanium and aluminium. This acts as a radiation shield and will slow down the aging effect that this radiation would have on the spacecraft's electronics. Europa Clipper's payload will include a variety of scientific equipment which will help us learn more about the Moon and the secrets it may hold beneath its surface. The Europa Thermal Emission Imaging System will use infrared to study the Moon's surface temperature, looking for warmer parts of the ice. It will also help map the surfaces, which will hopefully find hazard-free regions for future landing options on Europa. The Europa Imaging system consists of a wide-angle and narrow-angle digital camera with an 8-megapixel sensor that's sensitive to visible wavelengths of light, near-infrared and ultraviolet wavelengths. The system will allow scientific teams to have a better measurement of the surface elevations and will hopefully show signs of recent geological activity on the Moon. Europa Clipper's ultraviolet spectrograph will create images from ultraviolet light to help show what various atmospheric gases and surface materials are made of. The magnetometer instrument on the Europa Clipper has sensors that measure the magnetic fields around Europa. These fields can give readings to help ascertain the depth and salinity of the potential ocean, as well as the thickness of the ice shelf. The mass spectrometer for planetary exploration Europa will study gases in Europa's very faint atmosphere and measure the ions in them. These should give scientists a better understanding of the surface of the Moon and how the radiation from Jupiter alters the chemical compounds on Europa's surface. The mapping imaging spectrometer for Europa will produce pictures of the surface using infrared light, separated into various wavelengths. This will show the composition of surface materials rather than shape and colour that a normal camera would see. Scientists will use this to map the warmest hotspots on the Moon and help us understand the geological history of Europa. Europa Clipper's plasma instrument for magnetic sounding will measure the magnetic field, which will carry information about the ice shell's thickness, as well as the ocean underneath, depth and salinity. The radar for Europa Assessment and Sounding, Ocean to Near Surface, is an instrument that will send radio waves to the surface. These radio waves will bounce and penetrate different materials, and the instrument on the spacecraft will study the surface of Europa and will give a good indication to how thick the ice crust really is. The surface dust analyzer on the Europa Clipper will collect microscopic dust while in the Moon's atmosphere. This dust is tiny particles of the Moon's surface that has been released from meteorites striking Europa or from the theorized plumes of water getting vented into space. The instrument will measure the speed and direction the dust gained while travelling and will help scientists pin down the dust's origin from Europa's surface. With only a few years until the planned launch of the Europa Clipper, time will tell if this spacecraft's discoveries are as prolific as is hoped. Even if everything goes to plan and the Europa Clipper does launch in 2024, it won't reach the icy Moon until 2030. But in the next decade, humanity really could glimpse the first signs of life on a different planet.